In this video, I want to talk about the paper 3, the video inpainting. And this paper actually divided into two parts. One is removing the caption, and the other one is removing any object in the video. And actually, the first part, removing the caption, is the basic of the removing other objects. And the author also talked about the background of removing objects in image or video. Actually, removing unwanted items in an image have some very mature methods, but removing something in video still under development. And he compared his algorithm with several other algorithms, previous algorithms, and it looks like the best one. And this is the formula he used for each frame from time 1 to time t. He changed it to a prediction frame from time 1 to time t. And this one is supposed to be the same as the ground truth. So he mapped every frame from the input to an output frame. And for this part, he separated into two parts. One is the input frames in the original video, and one is a calculated frame from the previous result. And when he chose the frames as input from the video, he had to define what is the number n. So the author chose the number n as 2, and so it will use 5 frames, t and t minus n, t minus 2n, and t plus n, t plus 2n. And if the author chose the n as 3, he will use 2 more frames from the video, but it will cause a lot of more calculations. And also, the author have a stride in concept. If the stride is too little, for example, 1, so the author will choose t minus 2 minus 1t and plus 1 plus 2. That 5 frames may very close to each other. So when you put it in the neural network, they may generate very similar frame as the input. However, if the stride is too large, for example 10, so t minus 20 minus 10 plus 10 plus 20, these frames may differ from each other, so they may not look at the continuous planes. So the author used 3 as a stride. And after putting all the 5 images into an input, into encoder, and after some neural network algorithms, they get a frame, prediction frame here. And when he gets this one, they also take it as input to the aggregator. And so when we generate next frame, we both use the 5 frames here and the prediction frame calculated previously. So we can get a more accurate result. And this one explains the process here. So we take 5 frames and put them into 3D model. So this algorithm combines them together and try to remove all the captions. It might generate some distorted image at this area. So we use the output frame, prediction frame together with this distorted image and correct it as the real output. And each time we generate the real output, we use it as a previous image for the next frame. So at this point, everything will looks well much like the ground truth. And for the loss function, it has two parameters here. LR is the image reconstruction loss, and ST is temporal wrapping loss. And for the image reconstruction loss, it also has three parts here. And in the discussion part, the author talked about how the differences between all these loss functions. And also the author compared his algorithm to several other algorithms. And in this part, the author first used some transparent captions. And finally, he tested with a caption with black box. And in this part, we can see that the output is not as good as the other outputs, but it's still good enough. Oh, I will skip all the removing object parts in this paper, because when we look at the pictures, it's very clear that this algorithm is much better than all the other algorithms. And also in the class we discussed about the shadow here. It looks, well, when I first read about this paper, it makes me very interested in that, because something is removed, its shadow is there. But here, the last picture looks pretty good, because when people is removed, there's no shadow. So we can, in the future, we probably can add something here to make it another video. Okay, and for this part, I think we also discussed in class why we only remove captions, not the characters in the real video. Well, I believe part of that is because the captions are fixed position. So when we use a neural network, they may think, okay, this one fixed position is changed, but all the other characters in the video is movable. So it's scrolling up. So the neural network may think, okay, it might be a part of an animation. I think that might be the reason. I'm not quite sure. Okay, that's it. Thank you.